to you all to this session. Today our discussion in this video is about first topic is different forms of work transfer. Second topic is the heat transfer. Third topic is the zeroth law of thermodynamics. Fourth topic is the principle of thermometry. We will see one by one. First topic in this video is about different forms of work transfer. Previously we discussed about the displacement work or PdV work. We can call it is a PDV work also. Other than PDV work, now we are going to discuss one by one. First in this type of work is the electric work. Electric work. In this, let us try a current is flows through a resistor. Current is flows through a resistor. Let us consider a resistor as a system. Resistor as a system. It is a system. There is a work transfer into the system. Why? Because the resistor why? Because when the current is flows through a resistor, the resistor can drive a motor. The motor can drive a pulley. Pulley can raise a weights. So there is a work transfer through a resistor. Before the work here is by this electric work is, before that we need to know some important relation. Current I is equal to the dc by d tau. This is a important relations which are very useful, where I is the current in amperes, where C is the charge in coulombs, where tau is the time in seconds. Okay, where the work is the delta W is equal to the E into dc, where E is the voltage. dc can be write from this relation as a E into I d tau. This is the work transfer through electric resistor. The electric power will be as a it will be integral of dou W integral of E into I d tau. It is a rate, so tau get cancelled. EI is the electric power. E into I is the voltage, I is the current in amperes. This is the rate at which the work is transferred through a resistor. The second form of the work transfer, here from first onwards we are saying that the energy transfer take place, that is energy transfer take place only by the work transfer. Another one is the heat transfer. Only it is possible with the system and surroundings. Only we can see or notice at the boundaries of the systems only. Okay, here the work is transfer take place. Next energy transfer take place is the shaft work. Okay, shaft work. A shaft work. First we draw a simple diagram. Take it is a shaft. Shaft is connected with a motor. Say it is a motor. Say it is a motor. Motor is connected with a shaft. This is a shaft. Now we take shaft as a system. Shaft is connected to a motor, and shaft taken as a system is rotated by the a motor. There is a work transfer into the system because shaft can run the same. Shaft can, if you connect the shaft to a pulley can raise a weight. There is a work transfer take place by applying where the shaft can rotate. When the torque is applied on the shaft, the shaft will will turn with the angular displacement t delta t, okay, d theta, where t is the torque, t is the torque. Torque is applied through an angular displacement d theta. This is the angular displacement. Okay, right. The shaft work. The shaft work is the shaft work is the dou w is equal to t into d theta 1 to 2. And the shaft power can be t into d theta, tau 1 to 2. D theta by d tau is the omega, which is it can be read as in this form also, where omega will be the angular velocity. Omega is the angular velocity. This is the shaft power. Next other form of, other than the PDV work, is the pedal wheel arrangement. Next other type of work transfer is the pedal wheel work. Let us show a small diagram. Let us show a small diagram. Now the fluid in a tank. A fluid is in a tank. This is a fluid. Now fluid is considered as a system, is enclosed by a tank. There is a pedal wheel arrangement. There is a wire which is wound on this and hanging with a unit mass m. It is hanging with the unit mass m at a elevation of z height from the ground level. Now the fluid is taken as a system. Now fluid is taken as a system. Now a weight is lowered, the pedal will turn. There is a work transfer into the fluid system which get stirred since the volume of the system remains constant. So when there is a volume of the system is constant, there is a no pdv work, so the pdv work is 0. But the when it is lowered a unit mass from a height z, the energy, which is the energy is released, that is the potential energy, is the mgz, which is equal to the this energy is transferred into the rotational energy, which is the torque applied through this shaft or a rod through an angular displacement d theta from position 1 to position 2. This is the equal to the work, total work transfer do w, we can write mg delta z, the change in the height, integral 1 to 2 t into delta t, you can write. This is the pedal wheel work transfer on the fluid. Next other type of work is the flow work. Flow work, it is a name itself, it is a flow process. Flow work, fourth one is a flow work. Flow work is a flow process. It is an open system. Let us draw a diagram. Okay, flow work is a flow process or flow process in an open system. The energy transfer across a system boundary. The energy, let us take it is a, let's consider it is a system. It is a system. It is a control volume. This is the boundary of the system. The energy across a system boundary. This is a system. The energy across a system boundary as a result of the by a pump or compressor, a blower. Because of this external force acting on the system, when the fluid is flows over this, the fluid is crosses this boundary. So the energy crosses a boundary here to make fluid flow across the control volume. With the help of the pump, the fluid makes cross the system. The flow work is compared as a displacement work. How means, let us consider a pressure is acting an imaginary plane of the a piston acts normally to this direction. The work done on imaginary piston by an external pressure acting by the pump, we can write dou w of a flow work as a pdv. We know from a density equal to the mass by volume. Here the volume can be write as a m by rho is a density, m into rho can be write as a this. So we substitute this relation here. So rho is where volume is the m into v. So the pressure p can be write it as a v into delta m. That is the work in, the work out is the p in r1 p2 p2 m2. This is the flow work occurred due to the crossing the energy system boundary. This is the flow work. These are the four of the workflows across the boundary. Now, from basic point onwards, we are discussing that whenever the closed system and surroundings interact by the two ways. One is by the work transfer, next another by the heat transfer. Okay, only two ways the energy interaction take place. Okay, this is the mainly studies about the thermodynamics. What are the association properties changes occurs due to this energy transfer? This is the what thermodynamics mainly going to discuss. Suppose there is a system. Suppose there is a system. If it is not if it is not a non-adiabatic boundary, not a adiabatic boundary. This is a system on surroundings. This is the surroundings. If the boundary is not a adiabatic boundary. Adiabatic boundary means we already discussed that adiabatic, which does not allows the heat to flow through them, is the adiabatic boundary. So where there is a adiabatic boundary, there is no chance of Q transfer take place. But if it is not adiabatic boundary, there is a chance of heat flow. If in the case of it is not a adiabatic boundary, then the system temperature is depends upon the surroundings. Why? Because the system temperature is because there is a continuous heat flow take place. If there is a temperature difference between the system and surroundings is there means, so it is, we can define the heat transfer as a heat is defined as a form of energy that is transferred across the boundary by virtue of its temperature difference. By virtue of temperature difference. It is very clear. Okay. Now the definition. Heat is defined as a form of energy. It is also a form of energy, but it is transferred across at boundaries only due to the virtue of temperature differences. Okay, same as work, heat also only occurs only we can find at the boundaries only. Okay, now heat is only because of the virtue of the temperature differences. The heat transfer take place by the basically three modes of heat transfer take place. First one is by the, if the heat transfer take place between the two systems by a direct contact, it is called as a conduction mode of heat transfer. Next, if the heat transfer take place between the two systems when there is a vacuum between these two, the heat transfer take place by the mechanism of electromagnetic waves. This mode of heat transfer called as a radiation. Next, third mode of heat transfer is when the heat transfer take place between the wall and a fluid, we called it is a convection mode of heat transfer. Now if we come to the direction, about the direction of the heat transfer take place, about the direction of heat transfer, direction of heat flow always from higher temperature to the lower temperature only, higher temperature region to the lower temperature region only. For arbitrarily we can give a sign as a, if it is a system, heat flows into the system, then we can say a positive Q. If the heat is withdrawn from a system, then we can writing as a negative Q. The symbol Q is used for the heat transfer. It is a quantity of heat transfer within a certain time. Okay, heat is a form of a transient, like a work, we said. Okay, it is a boundary phenomena, so it is said to be a boundary phenomena since it occurs at the boundaries of the system. Energy transfer by virtue of temperature difference only. Energy transfer by virtue of temperature difference only, then it is a type comes under the heat transfer. In simple way I am going to tell you, see, wherever the energy transfer take place because of the temperature difference, it is, we can name it as a heat transfer. Due to the heat transfer, where there is a temperature difference exists between the two systems, there is energy transfer take place, it is category under the heat transfer. Other than any type, any form of work energy is transfer, that is naming as a work transfer. So finally the energy only transfer by the two ways. One is the work transfer, second one is the heat transfer. Heat transfer occurs only when there is a temperature difference or virtual temperature difference is there. Other than in all cases by the work transfer only the energy crosses at the boundary. It is very important point to be noted in this topic. Okay, sometimes temperature can be raised. Okay, heat flows through a system, there is a temperature rise of the system, but heat is not invariably cause the temperature. It is a sensitivity, it is a sensitivity a concept. Listen, okay, heat is not a inevitly causes a temperature, because heat when the temperature rises in a system occurs, there may not be due to a heat transfer. Okay, when there is a body temperature, if it is a tank, there is a fluid in the system, the temperature of the fluid, if it is rising, it is not only because of the heat is giving here, maybe it is due to the work transfer also, a body temperature can be raised. Okay, no need to be any confusion here. Temperature can be raised by the because of the heat flow or work transfer, it can be any way. Okay, temperature can be raised by giving the heat supply, or if we do some any work. Suppose if you connected a pulley, you keep on stirring, because of this work transfer, the fluid water gets raises its temperature. So temperature can be raised by not only the because of the heat flow, but also the work transfer. It is enough. Okay, the topic is we are discussing about the heat, so we are covering the basic annotations that heat is also a path function, like a work, it is also a path function, so it is a inexact a differential, so it is not a, okay, it is not a conserved quantity. Conserved quantity means it is a property. Okay, conserve quantity, if it is a pressure or a temperature, sorry, if internal energy, these are the conserved quantities. Okay, conserved quantities, but the Q and W, these are not a conserved quantity. So adiabatic process is one in which there is only work interaction between the system and surroundings. In the adiabatic process, in the adiabatic process, when the system is covered a boundary as a, if it is a adiabatic boundary, energy transfer take place only by which type of energy transfer I told? Only the work transfer, because it does not allow to heat flow, so it only the way by the energy transfer is the work. Latent heat. Here the latent heat means the heat, the amount of heat is required to cause the phase change in unit mass of substance at constant pressure and constant temperature is known as the latent heat of the temperature. Now I am latent heat of the latent heat. The amount of Q is required to change. Suppose a substance is going to change from a solid to a liquid. The amount of Q is required. The amount of Q is required to from change from one phase to the another phase at constant pressure and constant temperature, that is known as a latent heat. The triple point in thermodynamics, the triple point of a substance, triple point of the substance on temperature and pressure. If you draw this is a triple point. This is a solid region, this is a liquid region, this is a gaseous region. Gaseous a region. It is a point at which the three phases of the substance coexist in the thermodynamic equilibrium. Triple point is a point at which three phases are exist at one point, that is called as a triple point. Okay, if you talk about the some terminology, if a substance is changing from solid phase to liquid phase, we call it is a melting. We can name it as a melting. If a substance is changing from liquid to solid, we can call it is a freezing. A substance. If the substance is changing from liquid phase to the gaseous state, it is a naming as a vaporization. If a substance is changing from gaseous state to the liquid state, we can name it as a condensation. Similarly, if the substance is changing from solid region to the gaseous region directly, we can call it as a sublimation. Similarly, if a substance changes from gaseous state to the solid state, it is a deposition. The next topic in this video is about the concept of temperature. Quite usually, we all know from school days onwards what is the temperature. Temperature is a degree of hotness or a coolness of a body. Temperature is a degree of hotness or coolness of a body. The hotter body is the higher is its temperature. Cooler body is the lower its temperature. That's it. The units of the temperature in SI units. SI units of the temperature is the Kelvin. It is indicated with letter K. For daily basis application, we use in degrees Celsius. Degrees and Celsius. Okay, temperature is measured, generally the temperature is measured with the thermometer. If it comes to the temperature scales, mainly there are the three scales. Okay, first one is a Kelvin. Celsius case, that is indicated in terms of the degree centigrade. Next is a Fahrenheit scale. If your body is, if your body, okay, if you want to, if the boiling point of the water is the generally the 100 degrees Celsius, boiling point of the water, boiling point, boiling point of water, boiling point of water is 100 degrees Celsius. The melting point of the ice, melting point, melting point of ice, melting point of ice is from 0 degrees. At 0 degrees ice will start a melting. Okay, at 0 degrees onwards ice will start melting. Okay, if you want to, if you want to tell in terms of Kelvin, it is the 0 degrees is equal to the 273.15 Kelvin. In boiling point of 100, if you add this much, 373.15 0 degrees, okay, 0 degree plus 273.15 is the Kelvin. If you want to, if you know a degree Celsius, if you want to convert into the Kelvin, simply by adding 273.1, it is enough to convert the value in the kelvins. Okay, similar way, the absolute zero, absolute value, okay, the absolute zero, here it is a minus 273. If you want to boiling point of water, similarly for Fahrenheit also we have a one formula, that is any value can be converted the centigrade values into the Fahrenheit as a 5 by 9, 5 by 9 in degrees centigrade is equal to 1 Fahrenheit. This is a formula conversion, the unit conversion, we can use this basic formulas. This is 0 degrees can be write here as a 32 Fahrenheit, 100 degrees as a 212 Fahrenheit, and absolute zero value in terms of Fahrenheit can be write as a 460 degrees Fahrenheit. This is the basic information required before going to move forward topics. Next topic in this video is zeroth law of thermodynamics. Zeroth law of thermodynamics. When two bodies are generally when the two bodies are at a different temperature, if you, okay, if you keep at a different temperature, if you brought together to contact, after some time it will attain some same temperature. After some time it will attain a same temperature. First, initially at two bodies at a two different temperature, if you brought contact, after some time it will attain to a single temperature, a same temperature. Then the state of these two bodies are said to be in thermal equilibrium. Okay, if a body A, if body A is thermally equilibrium with body B, thermally equilibrium with body B, and separately body C also thermally equilibrium with body A, then we can say body B and body C also in the thermal equilibrium. This is the zeroth law of thermodynamics. Okay, once again, if your body is in thermal equilibrium with body B and separately with body C also, then body B and C are in thermal equilibrium with each other. This is known as the zeroth law of thermodynamics. It is the basics for the temperature measurement. Next topic in this video is the principle of thermometry. Principle of the last topic in this video is the principle of thermometry. Here, thermometry is generally used to measure the temperature. Measuring device which are used to measure a temperature. Here, what the basic principle here, it will take any property. Okay, the property of a material which changes with the temperature can be used for measuring a temperature. That is the principle of thermometry. I will write. Okay, any property of a material which changes with the temperature that can be used to measure a temperature. Example, if you go through example, we can come to a better understanding. Okay, suppose the expansion of the solid, gases, fluid can be used in the thermometer. Generally used a mercury thermometer. There is a mercury inside the thermometer which will be expand in terms of the lengthwise. When the temperature, if the temperature rises, the expansion in the mercury thermometer length will be expanded here. So it can be used based this principle only. Here the property of the material, here the property of the material, here length, the length is changes corresponding to the rise of the temperature. Okay, so this is the basic principle we are come to know, understand. Okay, what we understand here is the any property of the material which change with the temperature can be used to indicate or measure a temperature. Here mercury is rising or expansion in terms of length with the corresponding to the temperature, so it is used as a thermometry. Okay, expansion of the solid, gas, fluid are used to make a thermometer. The second example is the electric resistance thermometer. Electric resistance thermometer. Here also, in which the resistance of the length of wire is changes with the temperature. The length of the wire is changes with the temperature. Okay, the length of the wire is changes with the temperature. Next, a thermocouple thermometer. Thermocouple. Next example is a thermocouple thermometer. Thermocouple thermometer. Here it is. When the two junctions, in which the two junctions with the two different materials, when the two junctions, this is at the junction 1 and junction 2, this is joined with a material 1 and material 2, it will generate a voltage when these two junctions experiences with a different temperature. Generally one junction will be placed at the core, another one is the which you have to measure. So because of these two are at different temperature, it will corresponding indication generation of the EMF will generate. So here is the property changes with the corresponding increase of the temperature. Here EMF generate. So here also we can understand the principle of the thermometry. Next, the pyrometer. The pyrometer also, the fourth one is the pyrometer. Pyrometer is the It is a non-contact type, a pyrometer. Pyrometer is a non-contact type. Generally we use it in the railway stations or a hospital at the entrance, in which the temperature are adjusted by comparing by its color. It will reference to a color scale. There will be a color scale with the non-contact type. It will indicates in terms of the color. It will, when the color is some, it will corresponding there the chart, it will false, it will match to some, it will be decoded with the color into the number. It will gives the temperature. Here also the color is using the property of the here is the voltage is a property, here the length is a property, here also length is a property in general thermometers. Now I think it is clear about the principle of the thermometer. Any property of the material which changes with the temperature can be used as a thermometer. Okay, that is the principle of thermometry. Thank you. We covered all the topics in the is completed. Now we can come the next video.